So think about this. We all have phones, right? And we take, I don't know, hundreds of pictures without even thinking about it.
Instantaneously.
Yeah, exactly. But imagine a time when just one picture, a single image, needed heavy machines, toxic chemicals, and you had to stay completely still for ages.
That's where we're going today. All the way back to the invention that really changed everything, the daguerreotype.
Our mission, then, is to unpack that story. The science, the people, and how they figured out how to make light, well, draw its own picture.
Permanently. That was the key.
Okay, so to get why the daguerreotype was such a big deal, we have to start with something much older, right? The camera Obscura.
Right. And you have to understand, this wasn't a camera like we think of one. It was more of a tool.
A tool for artists.
Exactly. For centuries.
Yeah.
Think of a dark room or even just a box with one tiny pinhole in it.
And the light from outside shines through that hole.
And it projects a perfect but upside-down image onto the opposite wall. Artists could just trace it. It gave them perfect perspective, perfect shading.
It was like the ultimate drawing aid. But the image itself wasn't permanent.
Not at all. It only existed as long as the light was shining through. The second you moved the box or the sun went down, poof, it was gone. You had to draw it to save it.
So the big puzzle was how to make that light drawing stick around.
And they already had a starting point. Scientists knew for a while that certain silver compounds, silver salts, they darken in the sun.
Okay, so the chemistry was there. Sort of.
Sort of.
Yeah.
Because that created a huge problem. Let's say you use that to take a picture. The light makes the dark parts of your image.
Right.
But the moment you take your picture out into the light to look at it...
Oh, the rest of the plate would just keep getting darker until the whole thing turns black.
Exactly. That was the paradox. How do you stop the reaction? How do you fix the image so it doesn't just disappear?
Yeah.
That was the race.
And the first person to actually solve that puzzle was a French inventor, Joseph Nicéphore Niépce.
In 1826, yep, he creates the world's very first permanent photograph.
But his process was pretty different from what came later. He called it heliography, sunwriting.
Yeah, and he totally sidestepped that whole silver salt problem at first. He used a pewter plate, and he coated it with, of all things, a type of asphalt, bitumen of Judea.
Asphalt, like for roads.
The very same.
Yeah.
It has this weird property where it hardens when exposed to light. So Niépce puts the plate in his camera, and the bright parts of the scene harden the bitumen.
And the dark parts, the shadows, stay soft.
Exactly. Then he just washes the plate with a solvent, and all the soft, unexposed asphalt washes away, leaving the hardened parts behind.
And we've all seen that first photo, the view from his window.
It's incredible. And the most telling detail about it is the exposure time. It took about 8 hours.
8 hours of sunlight.
And you can tell because the sun moves so far across the sky that in the picture, there are shadows on both sides of the buildings at the same time.
Wow. So it's not a snapshot of a moment, it's a recording of a whole day.
Pretty much. So he proved it was possible, to make a permanent image. But 8 hours, that's not a practical product.
No way. He knew he had to get faster.
And to do that, he had to go back to the silver chemistry. He'd cracked the permanence part, now he needed speed. And for that, he needed a partner.
And that partner is Louis Daguerre. He enters the picture in, 1829?
Yep. And Daguerre's a totally different kind of guy. He's a professional painter, but more than that, he's a showman, a stage designer who created these huge, spectacular visual effects for theaters in Paris.
So he's obsessed with creating realistic illusions.
And doing it fast. The partnership was perfect. Niépce had the core science, Daguerre had the artistic vision, and this relentless drive to make it practical.
But the partnership didn't last that long.
No, tragically, Niépce died in 1833, only 4 years in. So Daguerre just keeps going on his own.
And he's the one who makes the big breakthrough.
He is. He moves away from Niépce's slow asphalt method and goes all in on silver. Specifically, he starts using these polished copper sheets that are plated with a thin layer of pure silver.
And that's not the only change he made.
No, this was the key. He discovered that if you expose that polished silver plate to iodine vapor, you create this thin, yellowish coating on the surface. Silver iodide.
And that stuff was way more sensitive to light.
Hundreds of times more sensitive than bitumen. Suddenly, exposure times dropped from 8 hours down to maybe 15 or 20 minutes. Still long, but now.
Now you could actually take a portrait of a person. It was finally possible.
And that changes everything. The daguerreotype was born.
Okay, so when you see one of these things, it's this beautiful, shiny, mirror-like object. But making one was, it was basically like running a small, very dangerous chemistry lab.
It was a whole ritual. Let's walk through it.
Okay, step one, the plate itself.
You start with that copper sheet plated with pure silver, and the polishing, my gosh.
Sure.
It had to be polished to a perfect, flawless mirror. Any tiny scratch, any speck of dust, it would ruin the final image.
And once it's a perfect mirror, you have to make it sensitive to light.
Right. Step 2, sensitizing. You put the plate in a sealed box with iodine crystals at the bottom. The vapors rise and react with the silver, creating that yellow-silver iodide coating.
And this all has to be done in the dark.
Total darkness.
Ugh.
Or under a special red light. Because the second it's sensitized, it's active. You have to use it right away.
Okay, so you have your plate, you put it in the camera. Now the hard part for the person getting their picture taken.
Step 3, exposure. The plate goes into this big wooden camera on a tripod. And yeah, for an early portrait, you're sitting there for 10, 15 minutes without moving.
15 minutes? I can't even imagine. What if you blinked? Or, I don't know, got an itchy nose?
The whole thing was ruined. You'd get this blurry, ghost-like smear. That's why photographers invented these metal headrests.
Like a clamp.
Yeah, basically a hidden metal brace clamped to the back of your head to hold you completely rigid, all while staring into bright sunlight to keep the exposure as short as possible.
Okay, so after all that, you finally have your picture.
Not yet. When you take the plate out of the camera, there's nothing there. It's invisible.
An invisible image.
It's called a latent image. The light has changed, the silver iodide on a microscopic level, but you can't see it. This brings us to step 4, development. And this was Daguerre's most brilliant and most dangerous discovery.
This is the mercury part.
This is the mercury part. He figured out that if you heated up liquid mercury, the fumes, the vapor, would actually develop the image.
How does that even work?
It's fascinating. The mercury vapor would only stick to the parts of the plate that had been hit by light. It forms this silvery white compound, an amalgam, right on those excited particles.
So the image you see is actually a silver mercury compound.
Exactly. It's the mercury that makes the invisible image visible.
And we have to stop here and just say mercury fumes are incredibly toxic. Breathing that in every day.
It was a massive health risk. Many of these early photographers suffered from neurological damage. It was the price they paid for this incredible new technology.
Okay, so one last step, right? To make it permanent.
Step 5, fixing. You'd wash the plate in a salt solution to get rid of all the leftover, unexposed silver iodide. That stops the chemical reaction for good. Now, finally, your image is permanent.
So after all that, polishing, fumes, sitting still forever, what did you get? What do these things actually look like?
They're really unique. The image is right on that polished silver surface, so it looks like it's floating inside a mirror.
Which makes them really hard to see sometimes without the glare.
Definitely. You have to hold it at just the right angle. And depending on how you hold it, it can look like a positive image or a negative. But when you get the light right, the detail is just insane. You need a magnifying glass to see it all.
But there was one huge problem with them, commercially speaking.
A huge one. There was no negative. Each daguerreotype is a one-of-a-kind original.
So if you wanted 2 copies of your portrait,
you had to sit through that whole 15-minute process twice and pay for it twice.
And they were delicate too, right?
Unbelievably fragile. You could literally wipe the image off with your finger. It was just like dust on a mirror. That's why they were always sold in these protective glass cases, usually lined with velvet. They were treated like jewels.
So even with all these issues, when the process was announced in 1839, people went crazy for it.
It was a global event. The French government actually bought the rights from Daguerre, gave him a pension for life.
And then they just gave the invention away.
They gave it to the world. For free. They said it was a gift from France. And because of that, the technology just exploded. It spread everywhere, almost overnight. People called it a miracle.
So what was the immediate impact of this miracle?
It completely changed society. I mean, think about it. Before this, only the super rich could afford a painted portrait. It was a massive status symbol.
But the daguerreotype brought that to the middle class.
Exactly. It wasn't cheap, mind you. A single plate might cost $5 or $10, which could be a week's wages back then. But it was a reachable luxury. For the first time, a regular family could have a perfect, realistic image of a loved one.
And portrait studios popped up everywhere to meet the demand.
And these little cased objects became treasured family heirlooms. It's also why you see so many post-mortem photographs from that era. If a child died, a daguerreotype was often the family's only chance to have a permanent image to remember them by.
That really shows you how precious a permanent memory was, something we completely take for granted.
It also connected people to history. You could see the real face of Abraham Lincoln or Frederick Douglass It made history feel real,
Yeah.
immediate.
But even with that huge cultural impact, the technology itself had some serious flaws.
A long list of them, yeah. The equipment was heavy, the chemicals were dangerous and expensive, the mirror surface had that awful glare, and the image was always reversed left to right.
And the biggest problem was still the fact you couldn't make copies.
That was the commercial killer. And by the late 1850s, something better came along. The wet plate collodion process.
Which used glass negatives.
Right, and with a negative, you could suddenly make hundreds of cheap paper prints from one shot. It was faster, cheaper, and didn't use toxic mercury. That was the end of the daguerreotype era.
So it really only had its moment in the sun for about 20 years.
A short but incredibly important 20 years. It proved that light could be captured forever. It was the invention that taught the world how to record itself.
And today, those little silver plates are these precious historical artifacts.
They mark the exact moment that our visual history truly began.
So the next time you just casually delete a blurry photo from your phone, remember that people once risked their health for one single permanent, perfect image. That's the legacy. Good luck with your studies.